We're going to go ahead and get started. I want to welcome everyone today. Thank you for joining our webinar today. This is about the In-Common Certificate Service. The title of the webinar is Self-Service, Security, and Strategy. And we have some wonderful In-Common Certificate Service speakers, people that actually use the service, that actually do real stuff with it. They're going to tell us all about their experiences and offer their expertise to us. So today, joining us to do just that, we have Clay Cooper. And Clay Cooper is from the Rochester Institute of Technology, and Clay is the Identity and Access Management Platform Engineer. We also have Brian Epstein joining us, and Brian is an IT manager of network and security and also the CISO at the Institute for Advanced Study. I want to thank both of you for joining us today and offering all that you have to offer us today. Really do appreciate it. We'll be taking questions in the Q&A part. You'll see a button down in your toolbar that says Q&A. That's where we'll be taking questions. And it's open to everyone. Thank you very much. And with that, I'll hand it off to Clay and Brian to get us kicked off.
Great. Thanks, Paul. I'm just going to go ahead and share my screen here. Great. So the Institute for Advanced Study promotes the disinterested pursuit of knowledge, unburdened from distraction for our scholars. We're a small institution in Princeton, New Jersey. We're not affiliated with Princeton University. We're a small school. We have 4 schools, but we only have about 20 faculty and about 130 staff. So, as a size comparison with RIT, you can see we're kind of tiny here. Our main drivers to talk about certificate lifecycle automation is the advent of 90-day certificates that are coming up, and also post-quantum cryptography. What happens exactly after RSA and ECC are no longer valuable because of post-quantum cryptography. And so that's what we'll go ahead and talk about today. In March of last year, the Google Chromium project announced their proposal to limit subscriber certificates down to 90 days from the previous period of 398 days or 13 months. We moved to 398 days in 2020. So we've done this before, where we've reduced the amount of time for those certificates in the idea of security and making sure that certificates are up to date and ready to be used. The change has been suggested for the second half of 2024, which, if I see correctly, we're solidly in right now. So this change could roll out at any time. And 90-day certs really make a manual certificate process no longer viable for many organizations, including mine, even as small as we are. So I wanted to talk a little bit about a quick history of modern cryptography as well, so that we can see what our other factor is for moving towards certificate automation. So in 1977, Ron Rivest, Adi Shamir, and Leonard Adelman created the RSA algorithm. It relied on a one-way function of factoring large numbers created by multiplying 2 primes together, also known as a semi-prime. And as you all know, multiplying 2 primes together is easy, but factoring a number back to its original primes is really hard to do. And then in 1985, elliptic curve cryptography was created, which relies on the mathematical properties of an elliptic curve. It uses this elliptic curve projected upon a 2-dimensional finite field for its one-way function. Its smaller and faster mathematics make it ideal for use on small devices without a lot of computing power. Quantum computing uses quantum mechanical properties such as superposition and entanglement to solve problems. Much like a bit in classical computers, quantum computers use qubits to represent data. Qubits have the special property of being able to exist in multiple states at the same time. Once observed, though, the qubits reveal their final state in a probabilistic manner. Qubits are prone to errors due to many factors, though, which slows down the efficacy of quantum computers and their development. Peter Shor created an algorithm in 1994 that used a theoretical quantum computer to drastically reduce the time needed to factor semiprimes back to the original primes. He created other algorithms as well to solve the discrete logarithm and period finding problem in a shorter amount of time. With the correct hardware, these algorithms could render all the previous discussed key exchange and asymmetric key cryptography systems unusable, like RSA and ECC. The concepts of Shor's algorithms are complex, but we'll do a brief overview of how they work. So the first thing to discuss is a Fourier transform. A Fourier transform is a way to convert a complex wave into its component waves. On the left side of the slide, we see a complex wave over time being transferred or transformed into a frequency graph on the right. And you can see which frequencies are involved in that complex wave on the left. And this is a useful practice in breaking down waves of any kind, like sound waves, to determine how they're formed. Here we have a complex sound wave at the top and its fundamental harmonics underneath that it's broken into. Using quantum Fourier transform, we can sequence the probability amplitudes for all the possible outcomes upon measurement. This ability to test everything with a single measurement shows us the power of quantum computers. Notice that unlike discrete systems, quantum computers and qubits give us a probable answer, which may change over multiple runs. The number of runs is very small, though, compared to the processing that a classical computer would need in order to figure out these same problems. So let's talk about the errors that happen with quantum computers. Here's the result of a 5-qubit quantum computer attempting to factor the number 21 into its component primes. And hopefully everybody here knows that the component primes are 3 and 7. 3 times 7 equals 21. So as you can see, the measured probability of 0 is the highest given, with 3 and 5 coming in close second and third. The paper that talks about this graph tells us that the 0 result is an error state and should be ignored. The initial guess given to this algorithm was 4, and one of the quantum computers, the IBM Casablanca test, came out as favoring 3 as one of the primes, which was the desired result. This test, given all the errors and all the confusion that you see here, was considered a successful factoring of the number 21 into 3 and 7. So where are we with quantum computers and breaking encryption? Obviously, 3 times 7 equaling 21 is not a big enough sort of answer to the question. So as we talked about, RSA was created in 1977. And 17 years later, Peter Shor designed his algorithm for breaking RSA with a quantum computer. 7 years later, IBM shows that Shor's algorithm can actually work on a quantum computer with 7 qubits. It factored the number 15 into its components 3 and 5. In 2009, NIST realized that this was going to be a problem eventually, and so it put out a survey to query for a quantum-safe algorithm. As they were doing that, IBM was working toward the factoring that we just saw of 21 down to its component primes in 3 and 7, and that was in 2012. Now, an attempt to factor 35 to its component primes 5 and 7 failed in 2019. They weren't actually able to do that. And then in 2024, after several rounds of competition, NIST ratified the new quantum safe algorithms as FIPS 203, 204, and 205, which is crystals Kyber, crystals dilithium, and Falcon. So let's review what we've accomplished. We were able to factor a 4-bit semi-prime, 15, and a 5-bit semi-prime, 21. Those in 2001 and 2012. And this last one that we attempted, a 6-bit semi-prime, failed in 2019 of 35. Now, what do we need to factor? Well, this is a 1024-bit semi-prime. This is sort of the smallest RSA semi-prime that people use on their websites and to protect data. Here's a 2048-bit semi-prime, which is much more is used much more often. And then here's a 4096 semi-prime, which isn't the largest number that I've seen. I've seen 8192-bit semi-primes as well. And so I honestly believe that someday we will have quantum computers capable of factoring large numbers like this, but I don't see that happening in the near future. So what about those post-quantum cryptography algorithms that NIST has been working on? Let's take a look at those. Oh, and IBM does plan on having a quantum-centric computer, supercomputer in 2033 with 100,000 qubits. Is that enough to break RSA? Well, it really depends on how error-prone those qubits are, which seem to be plaguing the quantum computer community right at the moment. So Crystal's Kyber, FIPS 203, is the example that I wanted to talk about just briefly. It uses techniques created in 2005 called learning with errors. Instead of being based on factoring semi-primes, discrete logarithms, or elliptic curves on two-dimensional finite fields, it uses multi-dimensional lattices and introduces errors to make discovery difficult mathematically, even for large-scale quantum computers without interference issues. The lattices that it creates are 3-dimensional, 4-dimensional, 5-dimensional, whatever dimension that they want, which again adds that complexity once you add the errors in order to make it theoretically difficult or impossible for a quantum computer to break. We'll never say actually, because it's very hard to prove these things. So where are we with post-quantum cryptography rollout if FIPS just ratified in 2024? Well, Cloudflare has rolled out a hybrid elliptic curve post-quantum cryptography algorithm, Crystal's Kyber, to the majority of its protected domains. And this includes Experts Exchange, for example, GitLab, for example. The Chromium browser started supporting this hybrid model, and so did Chromium-based browsers. Firefox is also supporting this hybrid solution, although it's not turned on by default. You have to go into the About config settings, search for Kyber, and you'll be able to turn those on. The Boring SSL fork of OpenSSL has support for post-quantum cryptography. And you can compile Nginx, Go, Rust, and a number of other utilities that we use on a regular basis, in order to use these post-quantum crypto libraries. And just last week on the 9th, Microsoft announced that it too was supporting FIPS 203, which is Crystal's Kyber, which is, really, really good news there as well. So enabling Kyber support in Chrome, again, it's on by default in the latest versions. This is how you used to have to do it. You went into Chrome, //flags, you search for Kyber and you would turn it on. Similar sort of thing in Firefox, you go to About config and you search for Kyber, and there's two little Booleans that you have to flip on, but it's pretty easy to do. And then you can go over to cloudflareresearch.com, their pq.cloudflareresearch.com. And you'll see in the middle of the screen there, it says you're using X25519, which is the elliptic curve portion, and Kyber 768 draft 00, which is quantum secure. And the way that this works with the hybrid sort of situation is the server has a normal elliptic curve certificate and key, and when it sets up the connection, the TLS 1.3 connection with the client generates the Kyber key exchange on the fly. And so when you actually look at certificates, you can't go out and buy a certificate today that has Kyber in it or any of the post-quantum crypto algorithms. You have to use sort of a hybrid model like this is using, which is great in itself, because then if somebody were to come out and say, hey, Kyber's broken, it's no good, you still have elliptic curve to back up on as far as that hybrid algorithm goes. So what do we need to do as professionals? Well, as all things, don't panic. Don't let your company panic. Good leadership will show calm, collective forward movement will prevail. Educate yourself and your leadership on the risks you face. Make sure this is treated as a priority plan for now. You have time, but don't become complacent. Start auditing your environment now to understand your exposure, and I'll talk about that in just a bit. You may be surprised to find out where you're using encryption, and that HVAC system has a certificate on it now, just like everything else. So it's good for you to have that and understand where you're using encryption, and also what type of encryption are you using. Are you still using SSL v2 somewhere that's exposed to the internet, and therefore is a great way for somebody to break into your network, because that's been insecure for many, many years now. What about your certificate expiry? Are they expired? Are you still using certificates with SHA-1 signatures, for example? Nothing on this list should be new to a seasoned IT professional. Technology changes all the time, and we have to constantly balance upgrading and updating against risk and productivity. There are easy to use tools to scan your environment to see what crypto algorithms you're currently using and the health of your certificates. Here's an example of using the open source free tool Nmap with the SSL cert script. And I'm running this against one of our mail servers, for example, here. It's our public mail server on port 25. And you can see that it's running and it's using an RSA 2048-bit certificate. You can see the signature algorithm is SHA-384, and you can also see its validity time and when that's going to expire. You can run this script very easily against your entire IP space to pull out all your certificates and figure out which ones are old, which ones still use SHA-1, which ones are expiring, things of that nature. So definitely encourage everybody to start running these scans and figuring out what you have internally and externally, so that you know what it is you're going to have to replace. The second Nmap script that I use frequently is called SSL enum ciphers. And don't be confused with the SSL, TLS is the new standard. If you're still using real SSL v3 and below, you should really turn those off. But the script still uses the word SSL in it. Here you can see the script is actually doing a connection against that same mail server, and it's trying out each one of its ciphers that it knows about in order to determine which ciphers that mail server is using. And the great thing about this script and this tool is that it actually grades them, letter grades from A through F, to tell you how strong or secure those ciphers are. And you can see that here I have two ciphers, one that's still running 3DES, one that's running RC4, both of which you can see down in the warning sections are vulnerable to different types of attacks. And so you can see my least strength for this service is a C. I find that these are really great to, sort of send out to, the various IT groups around campus, and let them know what letter grade their server's at, so that they can decommission some of those old ciphers. So definitely recommend running this script as well against your environment. And then what do we need to do based on that encryption audit? We need to make a plan. We need to find out what can be upgraded and what can't be upgraded. The things that can't be upgraded, definitely should be, cordoned off, put some sort of TLS proxy or protection in front of it, Cloudflare, something else of that nature. And then do a risk analysis of the things that are too old to be updated or, can't be updated. Do you buy a new one? Do you have replacement plans? Things of that nature. Then execute your plan when the technology becomes available. Now that Microsoft has released FIPS 203, start looking into how you can deploy that. What is your most critical data that you need to protect with post-quantum cryptography? And then remember that automation to certificate deployment is really important to consider, right? So this goes back to the 90-day certs. Chromium is the backend engine to most modern browsers, with the notable exception of Firefox, for example. And they're going to push the 90-day certs. And once they do, I'm sure Firefox will be, quickly coming up behind them to do that as well. And being able to deploy these in a large environment, we really need to rely on automation. So setting that up now will mean that it's all that much easier to deploy post-quantum crypto when it's made as well, because you'll already know your environment and how to push out those certs on an automated way. And remember, we're in this boat together. NIST describes module lattice-based key encryption mechanisms in FIPS 203. Note that NIST already plans on reevaluating the protocol every 5 years or sooner if needed. And we repeat that cyclical cycle of information security. I like to talk about the OODA loop, observe, orient, decide, and act. It's developed by military strategist and U.S. Air Force Colonel John Boyd. Remaining agile and following these steps keeps us moving in the right direction. So what are we doing at the Institute with our current new certificate process? Well, right now, an IT group, a business unit, makes a request via a ticketing system. Centralized IT creates the key and the certificate, the CSR. We submit that CSR to Cert Manager, Sectigo, via InCommon, and we approve the certificate for signing. And all of this is done through a script using the API to Sectigo. And then we take that certificate, private key, intermediate certs, and we put it into our password vault. At the moment, we're using Bitwarden. Again, using the APIs, we put that there in a shared collection that IT has access to, and then they log into Bitwarden in order to extract that key and put it into place wherever it needs to go. So as you can see, it involves multiple people. There's multiple places that we could have an error, although we did try to script as much of this as possible. Right, and manually installs the key and certificate. For renewals, we basically do the same thing. The only sort of difference is we reply to that original ticket asking if the certificate is still required. And this is sort of our audit step to make sure we're cleaning up old servers and services that we're no longer using. And then we follow the same procedure. We don't reuse keys at the Institute. We always generate new keys just in case something happened, and it really doesn't create a lot more work for our systems. Again, this is all manual today. Once we move to 90-day certs, though, this is not a tenable process. So as you can see, manual process, time-consuming, human error. And so we're going to keep certificate creation and deployment centralized. We're small enough that we can do that. And we have a trusted group of people that will be able to create those keys. We're going to start using the ACME protocol with the certbot binary to integrate with Sectigo to generate our certs. We investigated deployments using Sectigo's network agents, but we weren't comfortable with the amount of credential sharing that was needed to make it successful. Having to give the network agent our root or admin password to our F5 load balancers was not something we were really comfortable with. So we're gonna not use that product, but instead rely more on writing our own and using ACME and certbot to do that. And we're still gonna have some systems that we have to deploy manually. Yuck. That's what we're going to have to do. And so that's all I had. And so I'll hand things over to Clay unless anybody has a specific question for me.
All right. Thank you so much, Brian. My name is Clay Cooper. As I mentioned, I'm from the Rochester Institute of Technology in Rochester, New York. While I'm getting my sharing going here, we're gonna pop up a couple surveys here to just kind of get an idea of who's present today. So we can go ahead and do those while I get ready.
Okay, everyone should see a question pop up. The first question introduces some acronyms. We want to explain those real quick. RU and RAO, DRAO, MRAO. What those are is specific roles in the Sectigo Certificate Manager. Many of you are probably familiar with them, but for those who are not, RAO is Registration Authority Officer. That's like an organization-wide admin that spans the entire institution. A DRAO is a departmental registration authority officer. That's like a sub org admin. You can assign that whatever scope you want. As an RAO, you manage those DRAOs, and an MRAO is a master RAO, and that's us here at In Common.
All right. I think we can get moved on. Thank you for participating in the poll. Just want to make sure my slides are showing there. I think I'm good.
Yep, you're good.
Thank you, Brian. You know, great foundation there about why we need to talk about automating certs. Why is it important? So now I want to talk about how do we actually automate those certificates? How do we do it at scale? How do we do it in a secure way? So first off, IAS compared to RIT. RIT is much larger. We have about 20,000 students. Between faculty and staff, we're looking at about 3,000, 3,500 people. Our main campus is in Rochester, New York. We do have other campuses around the world. We have one in Dubai. We have one in Dubrovnik, which is where a lot of the Game of Thrones scenes were filmed on the cliffs. We have one in Zagreb, which is the capital of Croatia. We have a satellite campus in Kosovo, and then another established presence in Weihai, China. So we're pretty big. We have 11 colleges. That does not include those extra campuses I'd mentioned there. We are a private doctoral university. Carnegie lists us as an R2 university. So why does this matter? Scale and scope, basically. Brian mentioned, IES is very small. RIT is bigger. Our constraints, our opportunities are going to differ from yours. How we solve a problem is going to be different than how you solve a problem, or how you might need to solve a problem. So I'm gonna lay out what we're doing, what works for us. It may apply to you. It might not. Hopefully there's some stuff in here where you can learn and say, well, we're too small for that. We're too big for that. Our certificates are all issued to IAS, and so we don't care about Apache. I want to talk about our values when it comes to certificates. First, we want to reduce manual work. It doesn't provide a lot of value to my life to click through OpenSSL, making certificate requests and copy and pasting them in a cert manager. There are better uses for my time, my team's time, our sysadmins, and our app admins. We want to enable certificate service for all. Security is kind of everybody's responsibility here. We pay for a fantastic service, provided by Sectigo through In Common. Let's figure out how we can make that certificate work for whoever it might be. We want to ensure certificates are issued to the appropriate admins. Security is important. Certificates aren't just the lock in your browser. They are a security tool. They're preventing man-in-the-middle attacks. They're encrypting, my social security number when I log into certain sites. They're encrypting passwords. They're important. We want to make sure people who need the certs get the certs. The people who don't need the certs don't have access to them. We want to use off-the-shelf, community-supported tools where possible. And if custom tools are needed, we want to favor centralized, expert-built tools over individual tools. We don't want to expect our our edge admins to be writing scripts against some API, and one person's writing that script in Go, and one's using Rust, and one's using Python. The more we can centralize that cost, that burden, lets those people at the border, the app admins, the server admins, use just off-the-shelf tooling. And I will say, as part of this, custom tools, I'm going to talk a lot about ACME here. I'll cover what ACME is for a little bit. We know Sectigo provides the network agent and the REST API that Brian had mentioned. ACME clients exist. Network agent flavors for different tools don't exist. Scripting tools out there for the Sectigo REST API don't exist. The world's kind of converged down here on ACME. So if I talk about our current process, on the left side is a form for our ticket system. Put in your CSR, SANs if we need to add those within Certificate Manager. What signing algorithm do you want, and who do we notify, and who do we request an approval from? The right side is what fulfillment of this certificate request looks like. You'll notice rows 2 through 4 are just repeated copy and pasting. Copy from ticket system, paste into Sectigo Cert Manager. Copy from ticket system, paste into Sectigo Cert Manager. It's probably a pattern that many of you see today. Going back to our values, this does not reduce manual work. This is a form we want to get away from, except in very specific situations. We don't require everybody to go through this process. We do delegate out to our DRAOs access if they are authoritative for a subdomain. So the business school might have business.rit.edu. Computing college might have computing.rit.edu. So we do delegate that out. There are some self-serve. We do have some people using API tools out there as well. But again, those are all manual steps people have to take. So scale and scope, is it really that much work? Here's where our certificates come from. About 2/3 of them are issued through InCommon/Sectigo. That's through that manual ticket process, the ticket request and approval process. It's some through the REST API, which is, again, locally written code that we would like to get rid of. Some is through ACME for very specific situations. And then we have 658 certificates from Let's Encrypt or Zero SSL. So we're looking at about 1,600 tickets with 90-day certificates. If you divide 360 by 90, that gives you 5. So multiply these numbers, the InCommon signed certificates, by 5 per year, not by 4, because we're going from 365 days or 13 months down to 90. So our numbers for certs for the year is going to go up considerably. That's a lot of work. So what are our options when it comes to ACME? The two that are out there, we have Let's Encrypt that people hopefully understand and have used, and we have the Sectigo ACME implementation. In order to ensure security, these do domain authorizations. Let's Encrypt does domain authorizations. The options are HTTP 01 or TLS ALPN 01. You've probably never heard of ALPN 01. It seems to be very low adoption at this point. The third option for Let's Encrypt for domain verification is DNS 01. I strike it out because we're replacing our DNS management tools. We're not putting effort into providing a DNS API so that people can do verification. Revocation with Let's Encrypt is by the account holder. You deleted a server, the private key for Let's Encrypt went away. There's now no way to revoke that certificate. Non-routable servers, also called RFC 1918 space, that's your 10.0.0.0/18 or your 192.168.0.0/16, and there are a couple other nets in there. Those do not work with Let's Encrypt as far as the HTTP challenges or the domain authorizations. IP addresses and SANs, I couldn't find any definitive information on that, but I wanted to include it because we do know it's supported with Sectigo. Sectigo, domain authorization is either none with the universal endpoint. It lets you get a certificate for anything in a domain that's been validated for you, or by a list. I strike out the list because we don't have authoritative data for who owns what domains in our environment. We provide self-service DNS tools and computer registration tools, and people can set up their own DNS records. We've enabled them to do that, but we don't have a real clear way of taking that data and putting it, attaching it to an ACME key within Sectigo. Revocation, we know, is by an RAO or a DRAO. Non-routable servers are supported because there is no challenge component to the ACME implementation from Sectigo, and IP addresses are in SANs. So the value, going back to our values about what we want to do here, using off-the-shelf or community-supported tools. Both of these options support a plethora of ACME clients that are out there. That authorization I talked about, this is what it looks like with Let's Encrypt. This is part of RFC 8555 for ACME, if you want a good read. That's out there. The web server admin software talks to the Let's Encrypt server, says, I would like this cert signed. Let's Encrypt says, please put this payload at this location. Let's Encrypt then comes back through and asks your web server, did you put that payload at that location? And that's your verification that you are permitted to have a certificate signed with that domain name on it. If we switch to Sectigo, for reasons I'm not going to dig into here, that challenge and authorization step doesn't exist anymore. You get the key, or if you have an ACME account with Sectigo, you say, here's the domain, here's a certificate I want, and the Sectigo says, gotcha, I'm going to issue it to you, as long as you're either using the universal endpoint or you're using the other endpoints and have that domain listed on that account. I'll show pictures of this later, so it should come into a better focus then. Scale and scope. 11 colleges, we have distributed responsibilities. We have a central IT group, about 172 of us there. That includes app admins, database admins, server admins, our identity and access management team, our security friends. That's all rolled up in that 172 in central IT. We have about 67 people in distributed IT roles, and I'm calling it distributed IT roles because it includes somebody from public safety who's in charge of physical access and run servers. It includes some people who run a phone system. It includes various app admins within colleges or just dining departments. We have a lot of people. And our top level domain, rit.edu, is the hot commodity. People want to put their services in rit.edu. You see College of Computing Sciences, their IT people might have servers in cs.rit.edu, it.rit.edu, compsci.rit.edu, and we're not giving out subdomains for all of them. It's very blended, and there's not a clear line in the sand for who gets to use which subdomains. So if we look at the Sectigo ACME, the domain authorization is either none or by a list. That list can include a subdomain, star.business.rit.edu. So one of our values is ensuring certificates are issued to appropriate admins, those who have control of it. Option 1, do we grant star.rit.edu to everyone using Sectigo's ACME? Probably not. We don't want somebody over in our business college being able to set up or to acquire a certificate for our password changing site or our business or our HR site. Option 2, they can submit a request and we have an approval workflow for each host name that the domain the department owns. We first automate adding that to the list of domains that we're approved for in Cert Manager. Then we add it to the department in Cert Manager, and then we third add it to the Sectigo ACME account. What about students then? What department do we put students in? Right? How do we allow everybody to use this fantastic service we have? What about a department that only needs a couple host names? Is it worth going through all of that work just for them? This is what that looks like within the Sectigo Cert Manager. You set up a ACME account. It's called an EAB, External Account Binding. You attach domains to it, either a wildcard domain or specific domain. It is automatable through the REST API. We're going to add a third solution here. RIT ACME server does domain authorization through HTTP. We can still revoke certificates through as an RAO. It supports those non-routable servers, the ones Brian talked about, your HVAC system, right? It's probably not on the open internet. If it is, please have a conversation with somebody about how to fix that. Those servers can now answer an ACME challenge. IP address and SAN isn't supported. I talked about this with a developer yesterday. We can't figure out a good reason where we would even need that. So we're good with not having that in there. So what values does this provide for us? The reduced manual work. We're not filling out tickets. Use off-the-shelf community-supported tools where possible. This is ACME compliant. Any ACME client you have, for the most part, are compliant. There's a caveat there later. If custom tools are needed, favor centralized expert-built tools over individual tools. This is a central service built by the experts who understand ACME, who understand certificates. Security. If HTTP 01 is good enough for Let's Encrypt, then it's good enough for me. The validation is there. Providing a certificate through this service versus Let's Encrypt, we're doing the appropriate checks there. This enables certificate service for everybody. Going back to our values, ensure certificates are only issued to the appropriate admins. We've got some great authorization rules there. So introducing the RIT ACME proxy, or how hard can RFC 8555 be? Log in through University SSO. You get a nice page that explains what it is, what to do next. Next step is you can create an account. That can be a personal account, a group account. You can define what personal or group means to you. The difference there is visibility. Only the creator of the account can see a personal one. A group means anybody in a group, provided through that SAML payload, is able to see that the account and certificates that go with it. And I want to be clear here, the ACME account isn't a security control. It is loose connection to the responsible party by connecting SSO user to the certs. So if we see there's any abuse, we can revoke the cert, have a conversation with somebody, or revoke the key, the account key, have a conversation with somebody. The actual security is still handled through that HTTP authorization and challenge protocol that Let's Encrypt also uses. Once you have your key ID and key, you run your favorite command with your favorite tool. This is exactly the same as the Sectigo ACME binding process. It's just that we're issuing the key instead of Sectigo. Once you request a certificate, you can see the order. We provide some helpful information there. What was the IP? What was the user agent? So if you want to modify your user agent to say it was coming from this server or that server, go ahead and do that. You can see the status of the challenges. Were they valid? Did they fail? Are they pending? And again, this is using off-the-shelf ACME clients. Nothing special. You just need an EAB support for EAB bindings, and even then, we've come up with a workaround for that. The ACME proxy does the authorization, returns the certificate back down to the ACME client, returns the chain down as well. You can see all of your certificates. You can see all of basically any certificate issued through this service. With public certificate transaction logs, we didn't see any reason to hide it. So here you can see all the certificates that you've issued or your friends have issued. Behind the scenes, here's what the stack looks like. It's Django, which is Python, a Redis, MySQL cluster for the persistent storage, and then we're using the Sectigo REST API. So we've granted a REST API key that can issue anything in RIT.edu. And once the ACME proxy does its challenges and validations, asks Sectigo to sign the certificate, Sectigo hands back the certificate in chain, and we translate that back into ACME protocol and hand it off to the client. Authentication, as I said, is done through SSO. This is all running in one of our Kubernetes clusters. Both with the web interface and the ACME protocol interface. We've had to build a little bit of supporting machinery. This is what we call the RIT-PS ACME, short for PowerShell. It's a PowerShell module. It extends the community contributed POSH ACME client. Gets around some of the other the shortcomings. We've added some pre-issuance hooks, some post-issuance hooks, a notification hook. Bottom right is a picture of the Slack notification we get when a certificate has been reissued. We have an ACME toolkit for those tools that can't handle, or those ACME clients that can't handle external account bindings. This will bind for you and return back everything you need in order to shove it into your other ACME client. I prefer Get SSL. It does not support EAB. So this lets me do that. It also converts between PEM and JWK so that you can transfer some of your key credentials elsewhere. The thing with external account bindings is you do the binding one time, and that ties a private key that the server never sees to your account. So you need to hand around that private key to any servers that you think might need it. So what were the challenges? We found that clients are written to support Let's Encrypt servers, not the RFC. We've also found that Let's Encrypt server is not fully RFC compliant. We've been able to accommodate for this. We figure that's a reasonable action to take. We also have heterogeneous applications at RIT. We have Apache HTTP server, Apache traffic server, IIS, HA proxy. We have Kubernetes Nginx Ingress, which is managed through a tool called Cert Manager. That is not Sectigo Cert Manager. This is cert-manager.io instead of cert-manager.com. We have SMTP servers, MySQL servers. We have hardware lights out management. That's an embedded Java web server in a Dell box that was written 15 years ago. We have Jetty and Tomcat and Java apps. We have vendor-provided appliances. Here, import this into your VMware environment. We have load balancing via DNS. We also do load balancing via network unicast, and those have all presented challenges to us. Each one of these needs to be reviewed, solved, and automated independently. My advice, standardize. Please standardize on web server products and configurations. Automation for your certificates is also going to maybe mean automation for your web servers. Use a load balancer, regardless of the number of app servers. Load balancers typically support ACME protocol. It's not a silly configuration to have one server behind a load balancer. If you don't have a load balancer, you can kind of make your own if you want. You can use a standardized web server as a proxy in front of difficult apps. I've used IIS as a proxy. I've used HTTP proxy. I've used Apache as a proxy in front of applications. At RIT, we don't put Jetty or Tomcat out on the open internet. We put them behind Apache. That lets us say, here's a specific SSL, sorry, Brian, TLS and Cipher configuration that we know is supported. We know it's secure, and it lets us replace those certificates easier. Sometimes you have an application that self-manages the certs using a form inside the application. You need an admin to log in and paste PEMs. The goal here is not to find tools that support ACME or REST. The goal is to find a configuration that allows you to set it and forget it. Don't be disheartened because you can't find ACME support. There's some other combination of tools. I think of the Apollo 13 situation where they dumped a bunch of stuff on a table and said, make this square hose hook into this round pipe. Same thing. What combination of what tools you maintain and manage today are gonna get you to the finish line? This is automation. Set it, forget it. Also, remember to monitor it. Monitor your certificate expirations. Brian talked about monitoring your scanning for your TLS versions and your ciphers. Monitor that. Monitor your cert expiration. Monitor your cert chain. Automation lets you go faster at making bad choices. Make good choices. Monitoring's going to help you get there. And this is my last one. I want to thank Dave Lafferty. He was the primary developer on the ACME proxy. I said, hey, I have this crazy idea that I think can help us, potentially help the rest of the InCommon community. And he got real interested and read an RFC, and to me that's huge. Mike Bruckner was the developer on the PowerShell ACME module. And this whole ACME proxy is built off of GrindSA's ACME 2 certifier library. It speaks enough ACME for us that we were able to build a web interface on top of it to make it fit our unique needs. So that was everything. Thank you. Paul, back to you. Still muted, Paul.
Good grief. I was just talking away. Thank you so much, Clay. Thank you. Really appreciate that. That was an awesome talk. Thank you, Brian, as well. Really, really great stuff there. We have a couple of questions in the Q&A. The first one's for you, Clay. And basically, that's really awesome stuff you guys have worked on. Are you going to share? So you're going to be able to share with the Edu community that ACME proxy and that PowerShell toolkit.
Our intention from the beginning was to figure out a way that we could provide this back. We have one developer who's working on it. He does a great job with it, but obviously having more hands, willing hands to help out would be great. I think of Grouper, right? Grouper's really kind of focused in the Penn State area. But there's a lot of people contributing, and that's just become an awesome product. So we're going to definitely talk about it with the compliance and legal and whoever we need to, and see what we can do to maybe make it a little bit more white boxed and then hand it off.
Awesome. Thank you. The next question, also for you, Clay. Do you all have plans to open source? That's the same question. Yep, that's the same question. So just answer that. Okay. I don't have any other questions in the queue. Let me look in the chat. Nope, nothing in the chat. So that's really awesome. So fascinating that you're using the API with Sectigo. Was there advantages to using the API, the REST API versus ACME, and just making like a true ACME proxy and making ACME calls? Or is that just not how that software works?
We felt that the ACME between a bunch of servers to the proxy made a lot of sense, but found that the REST API was really fully featured enough that we could, come back and pull for the status later. We know there's some outages and some maintenance activities Sectigo does, and the API lets us be a little less encumbered by ACME, the ACME protocol itself, and a lot of those functions. The API is really great. It doesn't take a lot to program against, so it wasn't that big of a lift for us.
So are your downstream devices expecting like a really fast response, like 5 seconds or something, or what happens when it's down or something?
Yeah, we're working on a document of best practices. One of those best practices is going to be try to renew your cert early enough, and make sure your client can handle a failure. Most out of the box ones, the most community provided ones, can handle that outage. Or a non-response, and you put it in your cron, you put it in your scheduled tasks. 24 hours later, it's going to try again, and by then, Sectigo will have finished their
Okay.
maintenance or got it unstuck.
That makes sense. We had a question for Brandon. Can I use ACME for internal only systems, that is, systems without a public DNS entry?
So the Sectigo ACME doesn't do any challenge verification by default. So it doesn't matter with that one. With the RIT ACME proxy implementation, it needs to have a resolvable DNS entry from inside our network. We don't do a split horizon DNS, so it hasn't been an issue for us. But if you are doing an internal DNS view only, as long as the ACME proxy could resolve against that, you would be okay.
Awesome. Thank you. The next question says, we've been testing ACME and automating cert installs on multiple types of servers. Is there a way to have the certs be issued via the InCommon v2 profile? Does it matter that Sectigo is pushing out ACME profiled certs? If you use either the InCommon RSA or ECC endpoints or the ACME universal endpoint, then yes, all of those issue from the InCommon intermediate CA, the newer one, the one that's known as CA2. With respect to the universal ACME endpoint, that one is the most flexible one because you can specify what profile to use when issuing the certificate. So you can do multiple certificates. For example, if your school issues a special type of SSL certificates called IGTF certs, you can get those through the universal endpoint. Then I don't have any other questions in my queue. I don't see anything else in the chat. So I guess we can go ahead and call this with a few seconds to spare. Again, I want to thank everyone for joining. Really, really do appreciate you taking time out of your day to join us and to hear about the InCommon certificate service and to hear about the experiences of these two fine folks that took time out of their really busy schedules to not only join us today and tell us about what they do, but to prepare the materials that they did. Really awesome stuff. Clay and Brian, thank you again. My hat's off to you. So thank you all. You'll be receiving email with links to these materials. So thanks again. Have a great rest of your day.
Thank you.